Hi everybody, I'm Tony Yu with Sealing Technologies, and I want to go through our Bsides 2019 Crack the Code Challenge. I'm going to be demonstrating how to solve the PCAP portion of this challenge. I've downloaded from the my CloudShark account, the PCAP, and I'm going to be using Wireshark locally to solve this. You can use any number of tools that you want. It's up to your choosing. You can use CloudShark locally from the natively from the web, Wireshark locally on your system, Network Miner, any number of tools can be used to help solve this challenge. I'm going to be using Wireshark as it is probably the most popular packet analysis tool used to date. Before I begin, I want to open up the statistics and take a look at the capture file properties. I'm really interested in this duration piece here. This kind of tells me when the first packet was seen, when the last packet was seen, and what was the overall duration. We can see here there's about 48 minutes between the first and the last packet. So we know how much data, how many conversations, what we're really looking at inside of this PCAP. One of the next things I like to look at is the protocol hierarchy. This is going to give you sort of a percentage breakdown based on the volume of bytes and the number of packets in any recognizable protocols that Wireshark can pick out. So this is pretty helpful in just sort of diagnosing what is in the PCAP to begin with. What are you even looking at? Before you even open any of the packets, I like to start here so I know exactly what to target. Everything is a frame, an Ethernet frame, IPv4, so I don't have any IPv6. And looks like 100% of this PCAP is TCP. Here's a couple of protocols that it's picking out right off the bat, and we should keep these in the back of our heads as we start to peel back the onion on this PCAP. NetBIOS, which we know is going to be native Windows protocol. SMB2, probably for Windows file shares. HTTP, Hypertext Transfer Protocol. FTP, that's going to be pretty good. And so this is going to be the FTP control and data. All right, so we know we're going to be dealing with FTP, HTTP, SMB, and possibly others. Let's take a look. The next thing I like to do is before we even dive into any of these packets here in the table, I want to know who is talking to whom. And the best way to do that is to go ahead and grab the conversations. If we start with the leftmost tab, Ethernet, we see the entire PCAP is comprised of only two hosts talking to each other. Or rather, the capture point is only capturing between two hosts. If we look at the IPv4 tab, we can see that the entire packet capture, while there's lots of packets in here, over 3,000 packets, are only happening between two hosts. No IPv6, and between those two hosts that we identified in the IPv4 tab, there are 8 TCP conversations. So this is pretty unique, and here's what I like to do whenever I have a PCAP that has multiple conversations in it. And I know everyone sort of has their own organization method. I like to take this entire bit of information here, copy it as a CSV, open Excel, and I like to paste it in an Excel spreadsheet. And that's just so I can sort of treat that like a table of checkboxes, so I can check off each conversation as I dissect it, and I'm able to type in some notes. So in the first cell here, I'll paste in that information. Now we need to format it because it all just shows up as everything in one long cell. So I'll come over here to data, text to columns. I am pretty familiar with this procedure. We'll change the delimiter to a comma, just hit finish. And what that does is that organizes it in the same format that it was in the table from Wireshark. One of the last things I like to do is add a column here that says notes, and that's so I can go ahead and type out some notes here as we dissect some of this. Okay, so now we know we need to hone in on some of these TCP conversations. Let's go back to our Wireshark table here. What I like to do personally is I like to start with any clear text protocols that we have. Anything Telnet, anything HTTP, anything DNS, FTP. So we know we have FTP in here. We know we have HTTP. So let's start with those. I'm going to start with this HTTP session right here. I can right-click this and do Apply as Filter, Selected, and I want to do A and B, so anything that goes back and forth from the source to the destination. minimize this window, and this builds the filter for us to isolate this single conversation. So we can see this is TCP, we have the SYN, SYN-ACK, ACK, and then we see a GET for a file. So let's just right click and do follow HTTP, just so we can put that whole stream together and see what we have here. That file was the SSL Key Log file, and here is the data of that. One of the easiest ways I know to extract files from an HTTP session in Wireshark is to come over to the file, export objects, and because we have an HTTP session, hit HTTP. This will extract any of the files that it sees transferred in clear text and allow us just to extract them and save them. So I'm going to go ahead and hit save. How about I throw it on my desktop, new folder, Bsides 2. So what do we do with this keylog file? This is actually the client-side keys that your browser dumps out or can dump out if you set an environmental variable in your system, so that you can debug the SSL sessions. So this will allow you to actually decrypt SSL traffic in Wireshark. It's one of the easiest ways to do it. It is typically used by developers when they're developing HTTPS applications so that they can see the actual HTTP traffic that gets transferred inside of the encrypted session. So now that we have the SSL keylog file, let's make a note in our Excel spreadsheet. Let's do SSL keylog file. Next, our next clear text protocol is going to be, looks like FTP. So let's target this session right here. We're going to bring back up our Wireshark conversations. Target FTP, apply as filter, selected A and B. Open Wireshark, and this builds the filter for us automatically to isolate this single session. Now FTP works a number of different ways. The two primary ways are active and passive, right? So we're going to have to decide, make a decision on what we're seeing here, and then start to dissect it. So as you can see here, we have the Welcome to Ceiling Tech Bsides FTP server. The username was Bsides FTP. The password was Bsides FTP as well. Again, this is a clear text protocol, which is why generally it's frowned upon in most enterprises today. There's the directory listings, and as we go down here, entering passive mode, here comes a directory listing. I'm just hitting the down arrow as we go through this, and switching to binary mode, passive, entering passive mode, and retrieve clue C. That's RETR is the FTP command, retrieve clue C. So we know we have a file called clue C, but how do we get it out of this FTP session? Now I'm sure there's a cleaner way to do this, but actually I kind of wanted to talk about what we're seeing here, why it says entering passive mode 172, 16, 100, 81, 47, 79. What this actually is this is telling the FTP client to connect back to the server on this IP address, which is 172.16.181, and this port number. Now that port number is not 4779. That port number is actually a concatenation of the binary of both of those numbers. So although this is kind of a long-winded roundabout way to do this, I like to open up Calculator, hit the open it into the programmer, and enter the decimal value 47. Let's copy that binary, throw it in Notepad. Next, I want to enter the 79, which is here on the last comma, in decimal, 79. I'm going to copy this binary. Now I have these. I'm going to concatenate them together. Let's clear everything and let's enter everything in binary. So this is 00101111 and 01001111. And that equals decimal value 12,111. So now, what this is actually doing, this is the server telling the client, hey, connect back to me on this IP address and this port. Again, which is not 4,779, instead it's 12,111. So let's do TCP port equals 12,111. And here, just like a regular TCP session starts off with SYN, SYN-ACK, ACK, this is the beginning of the data channel of our FTP conversation. And you can see it here identified as FTP data. All right, let's right-click a packet in this conversation, file TCP stream. We can see in the beginning here, it says PNG. We can likely assume that this is an image file. You can save this off as any file type, run it through the Linux file program file, and it'll identify it as a PNG. What we want to do is, this is the ASCII representation of the data. We want to change it to raw and do save as. Save it as clue C, which I already have here because I've already been through this exercise. Open up our folder, and here is clue C, the image file PNG. Now this doesn't give us enough information to open the combination lock, so we got to keep digging. Now let's go back to our Excel spreadsheet and make some notes. This was the FTP command channel, and then we saw that we discovered it was port 12111, and this is the FTP data channel. And this is where we found clue C.png. All right, so that takes care of both of these. We've seen this one. Just to mark them. All right, so this leaves us with 1, 2, 3, 4, 5, 5 conversations left. The next one I want to attack is this 445. Most people will know this as Windows SMB. So we can see that in our conversations list. And again, if we right-click, we can filter right down to it. 445. Right-click, apply as filter, selected A and B. Close, minimize our conversations window. Now the network bias protocol, or the SMB protocol rather, has a lot to it. There's a lot of specifics on the protocol, especially as it's evolved from SMB1, SMB2, and now SMB3. I'm not even going to begin to break this down. I'm going to tell you the easiest and quickest way to do this, just like we did for the HTTP portion. Anytime I see SMB protocol in a PCAP, one of the first things I do is I go to File, Export Objects, and SMB, and just let Wireshark identify what it sees before you even spend the time spinning your wheels. It identifies a couple of things here: clue A, clue A, clue A, and SRV, SVC. Let's just do a save all. Throw these in our Bsides 2 folder. Select folder. Open our folder, and we see here we have clue A now. While we can begin to imagine what the number might be, this itself is not enough to solve the challenge. But I can, with confidence, mark this off of my list and say that on SMB, I found clue A PNG. All right, now we're more than halfway done. The next three I want to focus on are 443. Most of us will know that's HTTPS protocol. HTTPS is encrypted data. So what do we need to do to be able to see inside of that. Let's pull up our protocol list, our conversations list from Wireshark. And let's see A and B. This looks like one session. That's SYN-ACK. We see a three-way handshake, a client hello. Looks like we try to establish a session and then we get a FIN-ACK. All right, this it looks like it's a bit of a failed connection. We can go to the next one. If you look here, you can read that the packets are only 7 packets. Typically, you're going to have nearly 7 packets in just building up the three-way handshake and then the SSL handshake alone. So this one goes SYN-ACK, and then FIN-ACK right away, so it's being terminated. The next conversation has 642 packets. This is likely to contain much more data. Let's see what we can see. Our three-way handshake here, SYN-ACK. The client hello, server hello, client key exchange, and application data, and this starts all of the encrypted data. You're not going to be able to see what is in this encrypted data unless you have the decryption keys or that SSL Key Log file that we saw earlier. So if we go down to Edit, Preferences, Protocols, expand down to SSL, maybe it's TLS. TLS, here's where you can either input your private keys, or we can use our SSL Key Log file. Let's grab that from Bsides 2. SSL Key Log, hit OK. It's rescanning the PCAP, and it's applying that SSL Key Log file to our sessions. And what we see here is that we are still focused on that HTTPS portion of the PCAP, and what it's done is it's decrypted those values, so now that we can see there's actually an HTTP GET inside of that, and this is clue D, and this is something we haven't seen yet. So again, one of the easiest ways to do this is to jump right over to the File, Export Objects, HTTP, and now we can see that we have a new portion, a new file. I'm going to click this and hit Save. Dump it in our new Bsides folder. All right, now our folder contains clue C, clue D, and clue A. Most logic would tell you that you're missing clue B. So just to wrap this up, let's go back to our spreadsheet. Let's say HTTPS incomplete session. HTTPS incomplete session, and then HTTPS, and we found clue D PNG. That leaves us with one session left to take a look at, and that's going to be this first one. Let's open up our conversations window, apply as filter, selected A and B, close the conversations window. We're done with that now. So here we have a conversation here. As we begin to dissect this one down, we can see who is the client and who is the server. Typically, the high order ports, the high number ports, are your client side, as they're typically a random port number, an ephemeral port, and they go to a specific port on the server side. In this case, the server side is 123, and I'm using standard TCP protocol here. While that port number does map to an actual protocol, in this case, it was just a communications channel that I passed the image over. So let's right-click this one, do follow TCP stream. And we can see what we have here is a nice ordered set of data. If you scroll down through here, it is quite a bit of data. Nice and neat and formatted and ordered. If you take the time to try and figure out what this data is, you might recognize it. It's rather common. What I'm going to do is right-click here, select all, right-click again, do copy, and I like to open up one of my favorite sites here, CyberChef. Let's paste our input there, and let's take it from base 64. Now you're probably asking, why did I choose base 64? It could have been any number of things. It's true. I know what it is because I built it. But also, if you take a look at the data that was contained within that, what I just pasted in the input, you'll see that it matches the base 64 alphabet perfectly. Also, it is very common to try and encode things in base 64, and that's exactly what we have here. So I can download this, call it clueb.png. Excellent. So we have a clue A, clue B, clue C, and clue D. We can begin to put these together in a way that almost makes sense. So 02 is going to be one of your digits on the combination lock. And that's it. And that's how you solve the PCAP portion of the Crack the Code challenge. Thank you.